the session.
Let us now learn the objectives of the session. At the end of the session, you will be able to build up different angles using angle gauge, measure angle of a different component using plane bevel protractor. Let us look at the tools required for the procedure. Steel rule, bench vise, tri-square, files of different grades and sizes, marking media, dot punch, ball peen hammer, anvil, surface table, angle plate, vernier height gauge, drills of various sizes, drilling machine, chuck key, small flat chisel, hacksaw blade with frame, vernier plane bevel protractor, vernier caliper, lubricating oil. Let us now discuss about angle block and plane bevel protractor. Angle blocks are measuring tool for the alignment and measurement of precise angle. The ringing of the angle gauges should be carried as shown in the diagram. Gloves of cotton fabric or chamois leather must be worn to prevent corrosion. Protractor is an instrument used to construct and measure plane angles. The parts of bevel protractor are blade, protractor with graduations in degrees 0 degree to 180 degrees, spring-loaded lock nut. Let us now discuss about the building up angle using angle block set. The angle to be built up using angle block is 30 degrees, 38 degrees, 45 degrees, 53 degrees, 60 degrees. To build up an angle size of 30 degrees, the angle gauges required are ringing of selected angle block is to be done to build up an angle of 30 degrees. The required angle blocks are 25 degree, 5 degree. Total is equal to 30 degrees. To build up an angle size of 38 degrees, the angle gauges required are ringing of selected angle block is to be done to build up an angle of 38 degrees. The required angle blocks are 30 degree, 5 degree, 3 degree. Total is equal to 38 degrees. To build up an angle size of 45 degrees, the angle gauges required are ringing of selected angle block is to be done to build up an angle of 45 degrees. The required angle blocks are 30 degree, 15 degree. Total is equal to 45 degrees. To build up an angle size of 53 degrees, the angle gauges required are ringing of selected angle block is to be done to build up an angle of 53 degrees. The required angle blocks are 30 degree, 20 degree, 3 degree. Total is equal to 53 degrees. To build up an angle size of 60 degrees, the angle gauges required are ringing of selected angle block is to be done to build up an angle of 60 degrees. The required angle blocks are 30 degree, 25 degree, 5 degree. Total is equal to 60 degrees. Let us now learn to prepare specimens for measuring angles using a plain bevel protractor. File all the faces using bastard file. Ensure parallelism and perpendicularity using a tri-square. Apply marking media on face A. Mark to size of 37 mm by 47 mm using vernier height gauge. Witness mark on the workpiece using dot punch and ball peen hammer on an anvil. File and finish to the respective sizes using various grades of files. Ensure parallelism and perpendicularity using tri-square. Check the dimensions using steel rule. Prepare 4 such workpieces with the above mentioned procedure for preparation of specimens. Again, apply marking media on face A. Mark an angle less than 90 degree on specimen 1, say 30 degree, using plain bevel protractor. Mark an angle less than 90 degree on specimen 2, say 38 degree, using plain bevel protractor. Mark an angle less than 90 degree on specimen 3, say 43 degree, using plain bevel protractor. Mark an angle less than 90 degree on specimen 4, say 48 degree, using plain bevel protractor. Mark an angle less than 90 degree on specimen 5, say 59 degree, using plain bevel protractor. File and finish using different grades of files. Position the plain bevel protractor on specimen 1. Adjust the blade on the angled surface in such a way that the blade is in line with the angled surface and tighten the lock nut in this position. Read the angle on the protractor, which gives the angle of specimen 1. So the measured angle of specimen 1 is 30 degree. Position the plain bevel protractor on specimen 2. Read the angle on the protractor, which gives the angle of specimen 2. So the measured angle of specimen 2 is 38 degree. Position the plain bevel protractor on the specimen 3. Read the angle on the protractor, which gives the angle of specimen 3. So the measured angle of specimen 3 is 43 degree. Position the plain bevel protractor on specimen 4. Read the angle on the protractor, which gives the angle of specimen 4. So the measured angle of specimen 4 is 48 degree. Position the plain bevel protractor on specimen 5. Read the angle on the protractor, which gives the angle of specimen 5. So the measured angle of specimen 5 is 59 degree. To recap, we have learned to build up different angles using angle gauge, measure angle of a different component using plain bevel protractor.
So that's all about checking of angles with angle gauge, bevel protractor. Hope you have understood all the concepts and exercises. See you in the next session. Hello and welcome to this session on center drilling and drilling operation to required size. Let us begin with the session.
Let us now learn the objectives of the session. At the end of the session, you will be able to set the job on a 3-jaw chuck and set the tool to the center height. Set center drill in drill chuck of tailstock. Perform center drilling on a work held in a 3-jaw chuck. Drill through hole using drill. State the errors or defects in center drilling and rectification methods. Tools required: center drill, drill chuck, tailstock, drill bit, steel rule, outside caliper, lathe machine, surface gauge, turning tool, facing tool, drill bit of different sizes, chamfering tool. Select the round workpiece and ensure that the workpiece is 65 mm long and 45 mm in diameter. Hold the work in a 3-jaw chuck about 50 mm outside and true. Finish face the work with the facing tool. Ensure no pip is left out in the center and the face is at right angles to the axis. Remove dirt on the taper shank of the chuck and the tailstock spindle taper bore. Mount the drill chuck in the tailstock spindle. Fix the center drill of size A2002.5 by 6.3 or IS2473 into the drill chuck. Slide the tailstock over the bed until the center drill is close to the work face. Lock the tailstock in this position. Set the spindle speed to about 1000 rpm. Start the machine and slowly feed the center drill into the work by rotating the tailstock hand wheel. Withdraw the drill frequently from the workpiece to clean the chips and to apply the cutting fluid. Continue drilling until about 3/4 of the tapered portion of the center drill has entered the work. Ensure that uniform continuous pressure is applied during feeding and no extra force is given. After drilling to the correct depth, withdraw the tailstock spindle and remove the center drill from the drill chuck. Set the turning tool on the tool post and ensure that the tip of the tool and tip of the dead center are on the same plane. Perform turning operation for a length of about 35 mm. Reverse the job and hold 40 mm side in a 3-jaw chuck. Set the facing tool on the tool post and perform facing operations. Set the turning tool and perform turning operation to get a diameter of 40 mm. Let us discuss about through-hole drilling operation on lathe. Hold the workpiece in 3-jaw chuck in such a way that central drill side should face the tailstock end. Fix a drill bit size of 5 mm to drill chuck in the tailstock. Slide the tailstock over the bed until the center drill is close to the workface. Perform drilling operation to get through hole in the job with 10 mm drill bit. Perform drilling operation progressively with respect to the drill bit fixed in the drill chuck. Apply oil during the drilling operation to remove heat. Chamfer the drilled hole inside for a dimension of 1 by 45 degree. Chamfer the hole on another side to a size of 1 by 45 degree. To recap, we have learned to set the job on a 3-jaw chuck and set the tool to the center height. Set center drill in drill chuck of tailstock. Perform center drilling on a work held in a 3-jaw chuck. Drill through hole using drill. State the errors or defects in center drilling and rectification methods.
So that's all about center drilling and drilling operation to required size. Hope you have understood all the concepts and exercises. See you in the next session. Hello and welcome to the session on make square block by turning using 4-jaw chucks and perform drilling, boring and grooving operation. Let us begin with the session.
Let us now learn the objectives of the session. At the end of the session, you will be able to mark the square in round rod, face the work for squareness to all the sides, drill hole to required size, bore a hole to an accuracy of plus or minus 0.2 mm, select the recessing tool and cut the recess. Select the round workpiece and ensure that the workpiece is about 65 mm long and 85 mm in diameter. Hold the work in a 3-jaw chuck. True the job as per the procedure discussed in the previous session. Set the right hand facing tool in the tool post. Finish face the work with a facing tool. Reverse the job and hold in a 3-jaw chuck. Face the other end by following previously mentioned job sequences and ensure that the total length of the job is to be 60 mm. Turn and reduce the diameter of the workpiece to 79.2 mm. Apply marking media on the round face. Set the workpiece on a magnetic V block. Measure the diameter of the workpiece by using vernier height gauge. Mark a horizontal line at a distance which is equal to half of the diameter. Rotate the workpiece in such a way that the marked line should be perpendicular to the surface. Mark a horizontal center line at a distance which is half of the diameter of the round bar and is perpendicular to previously marked line. Set the height gauge from the center line of round bar for a distance of 28 mm. Mark a horizontal line which is parallel to center line. Rotate the workpiece for 90 degree and once again mark the parallel to center line. Continue the above step to mark a square side of 56 mm. Punch the witness mark of square on anvil using dot punch and ball peen hammer. Hold the job in 4-jaw chuck in a vertical position. Set the witness mark parallel to the chuck face. Perform facing operation to remove the extra material to form the side of the square. Repeat the same procedure to face the other three sides of a square. Ensure that all faces of the square should be 56 mm side. Hold the workpiece in 4-jaw chuck in such a way that the square should face the tailstock end. Fix the central drill to the chuck of tailstock and perform drilling operation. Fix the drill bit of size 5 mm to drill chuck in the tailstock. Perform drilling operation to get through hole in the job with 5 mm drill bit. Perform drilling operation progressively with respect to the drill bit fixed in the drill chuck to get a hole of 28 mm for a depth of 30 mm. Apply oil during the drilling operation to remove heat. Fix the boring tool to the tool post. Continue the boring operation to get the final diameter of 30 mm for the length of 30 mm. Fix the grooving tool to the tool post. Cut groove as per drawing with help of grooving tool. Check the dimensions of the finished workpiece. To recap, we have learned to mark the square in round rod, face the work for squareness to all the sides, drill hole to required size, bore a hole to an accuracy of plus or minus 0.2 mm, select the recessing tool and cut the recess.
So that's all about make square block by turning using 4-jaw chucks and perform drilling, boring and grooving operation. Hope you have understood all the concepts and exercises. See you in the next session. Hello and welcome to this session on parallel turning, step turning, parting, grooving, chamfering practice. Let us begin with the session.
Let us now learn the objectives of the session. At the end of the session, you will be able to parallel turn the work by hand feed method with various depth of cuts, turn step to the required diameter and length, groove by the traverse feed method, Chamfer the edges and check with a protractor. Set the parting off tool in the machine to the correct center height. Form a V groove and match with the template. Let us now discuss about task 1 of parallel operation. Hold the job in a 3-jaw chuck. Set the facing tool on the tool post, performing facing operation on one side of the workpiece. Perform turning operation to a diameter of 45 mm. Face the other end for a total length of 80 mm. Prepare 3 such workpieces for a dimension of 45 mm diameter and 80 mm length by following above job sequence. Let us now discuss about task 2 of step turning. Step turning operation is a type of turning operation in which a series of steps are created on the surface of the workpiece. Check the raw material size and ensure that the dimension of the workpiece has to be 45 mm and 80 mm length. Perform facing operation on both sides such that the total length of work should be 75 mm. Perform turning operation to reduce the diameter of workpiece to 42 mm for entire length. Hold the job in a 3-jaw chuck in keeping about 45 mm outside. Perform truing operation as per the procedure discussed in this session. Set the turning tool on the tool post. Perform turning operation until the diameter of the workpiece reduces to 30 mm for a length of 35 mm. So this above operation results in stepped workpieces as shown in the figure. Let us now discuss about grooving and chamfering practice. Check the raw material size and ensure that the dimension of the workpiece has to be 45 mm and 80 mm length. Perform facing operation on both sides such that the total length of the work should be 75 mm. Perform turning operation to reduce the diameter of the workpiece to 42 mm for entire length. Perform step turning operation to get a step of 42 mm diameter, 40 mm length and 30 mm diameter, 35 mm length as per the diagram. Mark a reference line from 30 mm diameter side at a distance of 6 mm, 11 mm, 18 mm, 23 mm, 30 mm using V tool. Set the square tool to the correct center height and hold it rigidly. Form a square groove 2.5 mm depth by 5 mm width at 30 mm from the end face. Set the radius tool to the correct center height and hold it rigidly. Form a radius groove 2.5 mm depth by 5 mm width at 18 mm from the end face. Set 32-degree V-groove tool to the correct center height and hold it rigidly. Plunge the V-groove tool to form a 32-degree V-groove, 5 mm width at 6 mm from the end face. Remove the burrs. Check the dimensions and formed groove by 32-degree template. Let us now learn parting of operation. Hold the finished workpiece of task 4 with the minimum overhang in a chuck. Set the parting tool in the tool post and choose the required spindle speed. Mark the length of the workpiece to be removed using tip of the parting tool. Continue to feed of a tool into the workpiece until the part is severed. Let us now learn about chamfering on lathe. Mount the tool and set center height properly. Set the speed. Lock the carriage. Move cross-slide and plunge the tool to the required size. Chamfer the 42 mm diameter step to 3 by 45 degrees. Reverse the job and reset it. Chamfer the 30 mm diameter step to 2 by 45 degrees. Check the length of chamfer by vernier caliper. If the protruding length is greater, support with center. Make sure the tool is perpendicular to the lathe axis. To recap, we have learned to parallel turn the work by hand feed method with various depth of cuts, turn step to the required diameter and length, groove by the traverse feed method, chamfer the edges and check with a protractor, set the parting of tool in the machine to the correct center height, form a V groove and match with the template.
So that's all about parallel turning, step turning, parting, grooving and chamfering practice. Hope you have understood all the concepts and exercises. See you in the next session. Hello and welcome to this session on turning practice between centers on mandrel for gear blanks. Let us begin with the session.
Let us now look at the objectives of this session. At the end of this session, you will be able to mount the work on a mandrel, machine the work held on a mandrel. A gear is a rotating circular machine part having cut teeth. A mandrel is a tapered or cylindrical axle or a bore inserted into a hole in a piece of work to support it during machining. The workpiece used to machine a gear is called as a gear blank. Tools required to complete this operation are steel rule, outside calipers, drill bits of various size, boring bar, reamer, vernier calipers, dot punch, ball peen hammer, mandrel and mandrel block, outside micrometer, lead hammer and lubricating oil with can. Let us now learn the sequence to prepare the job for creating a gear blank. Check the size of the raw material. Hold the job on a 3-jaw chuck and check the trueness. Mount the facing tool on the tool post. Face one end of the job. Fix the drill chuck on the tailstock. Drill a hole on the workpiece using a center drill. Enlarge the diameter of the hole up to 15 mm using drill bits of 6 mm, 9 mm, 12 mm and 15 mm. Fix the boring bar on the tool post. Perform boring operation to obtain a hole of 26.98 mm. Ream the hole to 27 mm with H7 tolerance range. H7 tolerance range for 27 mm diameter hole is 27 mm to 27.025 mm. Remove the burrs from the edge of the hole by chamfering. Measure the bore size with vernier calipers. Mark the thickness of the workpiece to 20 mm from the faced end. Punch on the marked line using dot punch and ball peen hammer. Reverse and fix the workpiece on the chuck. Conduct facing operation to bring the thickness of the workpiece to 20 mm. Let us learn the sequence to drive the mandrel into the hole of the workpiece. Select the correct size of the mandrel to suit the hole of the workpiece. Clean and apply a light film of oil or soft grease on the diameter of the mandrel. Clean and lubricate the hole in the workpiece to prevent seizing when the mandrel is pressed into or out of the work. Insert the small end of the mandrel squarely into the hole by hand. The mandrel can be driven into the whole workpiece by light hammering using a lead hammer and mandrel block. The mandrel can also be driven into the workpiece using an arbor press. Place the workpiece on the arbor press table. Let the chamfered end of the hole face downwards. Press the mandrel firmly into the workpiece. If the mandrel is forced into the work tightly, it may distort or damage the bore of the workpiece. The workpiece is pressed on a solid plain mandrel and is held in position at the center of the mandrel length only by friction. Take all cuts towards the large diameter end of the mandrel and avoid taking heavy cuts. Let us now learn to turn the gear blank between centers on a mandrel. Hold the mandrel mounted with workpiece on the lathe in between the centers. Mount the turning tool on the tool post. Perform plain turning operation to reduce the diameter of the workpiece to 92 mm. Check the diameter of the machined gear blank with vernier calipers of 75 to 100 mm range. To recap, we've learned to mount the work on a mandrel, machine the work held on a mandrel.
So that's all about turning practice between centers on mandrel for gear blanks. Hope you have understood all the concepts and exercises. See you in the next session. Hello and welcome to this session on fitting of dissimilar materials, MS in brass, aluminium in cast iron, etc. Let us begin with the session.
Let us now look at the objectives of this session. At the end of this session, you will be able to set the job on a 4-jaw chuck, turn to the required diameter and length, bore a hole to an accuracy of plus minus 0.02 mm with a tool. Fit the job part task 1 and 2. The tools required for this exercise are steel rule, outside calipers, vernier calipers, surface gauge, drill bits, boring tool. Fitting is related to the assembly of parts after bringing the dimensions or shape to the required size or form to secure the necessary fit. Let us now understand the sequence to drill and bore a steel blank for fitting. Check the size of the raw material as 42 mm length using steel rule and outside caliper as 50 mm diameter. Set the 50 mm diameter job on a 4-jaw independent chuck with maximum possible projection. True it with the help of surface gauge. Set the turning tool on the tool post with correct center height. Select the correct RPM. Face one end and turn diameter 48 mm to a length of 20 mm. Insert the drill chuck with center drill into the tailstock. Perform drilling operation using the center drill. Enlarge the diameter of the hole to 24 mm using 6 mm, 9 mm, 12.5 mm, 16 mm, 20 mm and 24 mm drill bits, one after the other. The drilling should be carried throughout its length. Drill the job up to diameter 24 mm through its full length. Set the boring tool on tool post to correct center height. Perform boring operation to obtain 25 mm diameter hole throughout its length. Reverse and hold the job in the chuck and through the job. Face the end and maintain the total length 35 mm and turn diameter 48 mm remaining length. Perform turning operation to obtain an external diameter of 48 mm throughout the length. Let us now understand the sequence to turn the brass bar to fit into steel cylinder. Check the size of the raw material using steel rule to the length of 42 mm and outside calipers as 32 mm diameter. Hold the job diameter 32 mm workpiece in a 4-jaw chuck with maximum possible projection. True it with the help of surface gauge. Set the tool on the tool post with correct center height. Set the correct RPM for non-ferrous metal. Perform the facing operation on the end. Turn the job up to the diameter 25.04 mm. Set the chamfering tool and chamfer the edge. Reverse and fix the job. Perform facing operations to reduce the length to 35 mm and turn the entire length to 25.04 mm. Fit part 1 and part 2. Set the assembled job on 4-jaw chuck and true it with the help of surface gauge. To recap, we have learned to set the job on a 4-jaw chuck, turn to the required diameter and length, bore a hole to an accuracy of plus minus 0.02 mm with a tool, Fit the job part task 1 and 2.
So that's all about fitting of dissimilar materials. MS in brass, aluminium in cast iron, etc. Hope you have understood all the concepts and exercises. See you in the next session. Hello and welcome to the session on knurling practice in lathe. Diamond, straight, helical and square. Let us begin with the session.
Let us now look at the objectives of this session. At the end of this session, you will be able to mount the workpiece on a 4-jaw chuck. True the job in the 4-jaw chuck with a surface gauge. Turn the component as per the drawing and maintain the required dimensions. Set the knurling on the tool post. Knurl the job as per the drawing. Let us now learn about knurling. Knurling is a manufacturing process typically conducted on a lathe whereby a pattern is rolled into the material. It creates different patterns of straight or diagonal lines and diamond shape on round or cylindrical parts. This pattern increases the surface friction of the part and provides excellent aesthetic appeal. The tools required for this exercise are steel rule, outside calipers, surface gauge, vernier calipers, knurling tools, parting tool, chamfering tool, facing tools, lubricating oil with can. Let us now learn the sequence to perform knurling operation. Check the size of the raw material with an outside calipers and steel rule. Hold the material securely in a 4-jaw chuck such that 50 mm is projected outside the chuck. True the job with a surface gauge. Perform facing operation for the one end. Perform turning operation for a length of 30 mm to obtain a diameter of 40 mm. Set the diamond knurling tool in the tool post and align with the center of tailstock. Select the suitable speed for the knurling operation. Feed the knurl and make the knurls to connect the work periphery by the cross-slide hand wheel. Move the carriage until about the face of the knurling roll overlaps the end of the workpiece, which helps to produce a true pattern. Start the lathe and feed the knurling tool into the work by the cross-slide. Knurl the surface till a diamond shape is formed. Ample coolant is to be applied to the workpiece being knurled. Mount a chamfering tool on the tool post. Chamfer 2 by 45 degrees at the end. Reverse and hold the job in the chuck. True the job with a surface gauge. Perform facing operation for other end so as to maintain the length of the workpiece to 80 mm. Perform turning operation for a length of 50 mm to maintain a diameter of 25 mm. Ensure the dimensions with vernier calipers. Chamfer to 3 by 45 degrees at the end with a 45-degree chamfering tool. Undercut and maintain diameter 23 and groove with a 5 mm width grooving tool. Deburr all sharp edges. Similar sequence is followed to obtain knurled patterns with straight lines, diamond lines, helical lines, square shape using appropriate knurling tools. Do's and don'ts. Avoid overhanging of the tool. Use aluminium pieces for packing to avoid marks on the knurled surface. Never operate a lever when the machine is in motion. Do not keep any tools on the moving parts of the machine. Use a suitable coolant. Clean the knurl with a brush. Use a fine feed for knurling hard metals and a coarse feed for knurling soft metals. To recap, we have learned to mount the workpiece on a 4-jaw chuck. True the job in the 4-jaw chuck with a surface gauge. Turn the component as per the drawing and maintain the required dimensions. Set the kerning on the tool post. Kern the job as per the drawing.
So that's all about knurling practice in lathe, diamond, straight, helical and square. Hope you have understood all the concepts and exercises. See you in the next session.
Namaskar and a very good morning. I am K.K. Mishra from Ministry of Power, Government of India, and I am here to discuss and talk about the various initiatives taken by Government of India, Ministry of Power regarding digital initiatives. This is a creation of an ecosystem which enables consumer not only to facilitate the various services but also empower and